I am Dr. Ali Wagdi. I am Associate Professor of of Operations Research and Statistics. I am with Wireless Intelligent Network Center, School of Engineering and Applied Sciences, Nile University, and I am also with Department of Operations Research, Faculty of Graduate Studies for Statistical Research, Cairo University, Egypt. My talk today about nature-inspired algorithms and its applications. Outline of my talk will be introduction to optimization, classifications of meta-heuristics or nature-inspired algorithms, the source of inspiration for nature-inspired algorithms, engineering applications, and also I will show you real-world application and example. First of all, optimization. What is the meaning of optimization? I try to, okay. Optimization is the process. Optimization can be defined as the process of finding the best combination for a set of decision variables to solve a certain problem. Besides, optimization arises in many fields, different disciplines, and countless applications. Actually, we encountered in our daily life. Hard optimization problems arises in huge number of applications in real life, in which it is very hard to reach the global optimum solution. This is the meaning of hard optimization problems. Actually, many optimization or many algorithms try to tackle this kind of problems. It can be classified according to criteria or to two classes, exact methods and also approximate methods. First of all, what is the meaning of exact methods? Exact methods means using classical nonlinear programming techniques may fail to solve, using classical linear programming techniques to solve such problems. However, these techniques may fail to solve such problems because these problems usually contain multiple local optima and also show different challenging characteristics such as high nonlinearity, non-convexity, non-continuity, non-differentiability, and large scale. I can show you such problems just. This is some types of these challenging problems in just 3 dimensions, x1, x2, and the objective function. It's a very complicated functions. Additionally, most real-world problems are limited by a set of constraints. I try to minimize this, okay. Additionally, most real-world problems are limited by a set of constraints and has many contradictory objectives. And also, besides, it's affected by mixed types of variables, continuous, discrete, integer, and binary variables. So all these types of problems are very complicated to be handled. In combinatorial optimization, also exact methods perform compare or fault enumeration. I mean here, combinatorial optimization means we are interested or we are dealing with a discrete space, not a continuous space. In combinatorial optimization, exact methods perform complete or full enumeration of all possible alternatives and comparison of all of them to pick the best solution. Can be very expensive or even impossible to more complicated problems, such as a very simple example. And I think it is a well-known example, traveling salesman problem, knapsack problem, or also quadratic assignment problem. All these problems are typed or belongs to combinatorial optimization. Exact methods are guaranteed to obtain an optimal solution in a reasonable time unless the problem is classified as NB hard problem. This is the main merit of using exact methods, which is guaranteed obtaining the optimal solution. However, it is not guaranteed as it must be obtained within a suitable time. In case of this problem, it is classified as NP hard problem, which means there is a non-polynomial time exists to perform total or complete enumeration as the size of the problem increases, as the time will be exponentially increases. This leads to very high computational time. Therefore, exact methods are very good and can be used in very small problems. However, in case of large scale problems, it cannot be solved within current time. Again, as a result, finding the more accurate solutions in a short period of time for unconstrained, constrained, or many objective optimization complex nonlinear problems is the main goal of all optimization meta-heuristics, and still widely open to research. All of these facts encourage us, I mean here my team, to employ our new algorithm, which is called gaining, sharing, knowledge-based algorithm to solve these types of a challenging problem. Maybe in another tutorial or another conference, I will give you an introduction about my novel algorithm, and it's noteworthy to mentioning that we are the first Arab team that developed such algorithms, which belongs to evolutionary algorithm. Now, meta-heuristics or nature-inspired algorithms, a new kind of approximate algorithms that has been developed and also known as a meta-heuristics. Meta-heuristics is widely used over the last 3 decades because of really this is the main features or positive side of using meta-heuristics: simplicity, ease of implementation, ability to avoid local optima, but not guaranteed, deals with with derivative-free problems. No need to know more information about the problem. Just the objective function is more enough. Two important characteristics of meta-heuristics are exploration and exploitation. I mean that the successful meta-heuristic is the one that is able to balance between these two contradictory aspects, which is exploration and exploitation process. Exploration means or indicates the ability of the algorithm to discover new search areas. While exploitation, we have to focus on finding the best solution in a promising region of the search space. Thus, the use of approximate methods has gained much more attention during the last 3 decades. In approximate methods, the main target to obtain a satisfactory solution in a reasonable time, which means that approximate methods do not guarantee to reach the global optimal solution. However, it guaranteed to find the near optimal solution or even local optima within a very reasonable time. Generally speaking, we have many types of nature-inspired algorithms like heuristics, hyper-heuristics, and meta-heuristics, selecting alternatives by only looking at parts of the solution space. I mean here, the main difference between the process of heuristics, hyper-heuristics, and meta-heuristics, they do not need to perform a complete enumeration like exact methods. They just interested in partial enumeration or partial search within the region of research, of search, sorry, or search space. It performs partial or incomplete enumeration. This provides approximate solution, but not necessarily optimal ones. Again, we have 3 different terminology, which is heuristic, hyper-heuristic, and meta-heuristics. Heuristic is any approach or algorithm to solve a special problem that is not guaranteed to be optimal. There are many types of techniques that has been built or developed to solve like traveling salesman problem, assignment problem. All this method are special purpose techniques. They are designed originally to deal with these types of problems. On the other hand, we have another type which is called hyper-heuristics, are the heuristics to choose the heuristics. It means that it can be considered as high-level strategies that manage a set of low-level heuristics and work either by selecting a heuristic from available heuristic or generating a new heuristic from components of available heuristics at each decision point. So the main role of hyper-heuristic is to determine the most efficient or the most effective one of some heuristics or pool of heuristics that is very suitable to solve such any problem during any iterations of the search process. Thus, a hyper-heuristic operates in a search space of heuristic, selecting and applying a single or a combination of low-level heuristics from a given set of heuristics. Hyper-heuristics, the main role of hyper-heuristics is to manage the sub-heuristics or to determine which one is more appropriate to be selected or to be used within or through the solution process. For example, there are many heuristics to add, remove, swap, selection, and you have to choose from during the optimization process. This is the main role of hyper-heuristics. On the other hand, regarding the meta-heuristics, there is a fundamental difference between hyperheuristic and a meta-heuristic, as the latter directly operates over the search space. Actually, meta-heuristics is a general purpose technique. Uh, as I have just told you that meta-heuristics operates over a search space of solutions to problem under consideration. In other words, hyper-heuristic search for a good heuristics to solve the problem at hand, whereas a meta-heuristic searches for a good solution to a problem at hand. Actually, the motivation of the development of hyperheuristics comes from the fact that performance of different heuristics may vary significantly depending on the specific characteristics of the problem instance under consideration. Maybe during the optimization problem, we have to use multiple of heuristics, and not all of them are very or appropriate during the optimization problem. Maybe someone or one of them maybe is very good in the initialization process, maybe another one is good within the middle of the search process, and maybe another one is very good with the late steps of the search process. Moreover, individual heuristic may be partially effective at a certain stage. Again, I try to repeat the same sentences at certain stages in the search process. For example, when exploration is more important than exploitation while performing poorly at other stages. This is why we have to choose the best one during the optimization process. Therefore, it is fair to expect that several heuristics applied in an appropriate manner may produce better solutions than individual using any single heuristics. It has been noted that a meta-heuristic may also be used as a low-level heuristic and hyper-heuristic. I mean that hyper-heuristic can manage heuristic and also may manage hyper-heuristic. And also hyper-heuristic may be used inside meta-heuristics. Now, there are many classifications or many types of classification to classify the meta-heuristics. Firstly, it can be classified as nature-inspired versus non-nature-inspired algorithm. Then there are nature-inspired algorithms like genetic algorithms and ant algorithms, and the non-nature-inspired ones such as tabu search and rated local search, which means nature-inspired, I mean that any technique that mimic a specific process from the nature. On the other hand, there is another type of classification, which is meta-heuristics, which is population-based versus single-point search. Genetic algorithms are population-based because they are use a set of solutions or agents at the same time. On the contrary, algorithms working on just single point at any time are called trajectory methods like tabu search and iterated local search and also variable neighborhood search. They all share the property of describing trajectory in the search space during the search process. However, perform a search process which describes the evolution of a set of points in the search space, which is called population-based or meta-heuristics. We have also another type of classification, which is based on dynamic objective function versus static objective function. While some algorithms keep the objective function given in the problem representation as is, some others, like guided local search, modify it during the search to escape from local minimum by modifying the search landscape. Accordingly, during the search or the optimization process, the objective function is altered by trying to incorporate information collected during the search process. Again, also one single neighborhood versus various neighborhood, which is very important. One single neighborhood structure means the fitness landscape topology does not change in the course of the algorithms. Other, which is various neighborhoods, such as variable neighborhood search, which is very effective algorithm, use a set of neighborhood structures which gives the possibility of diversity the search by swapping between fitness landscape. This means that maybe the structure of the search space changed during the search process. Finally, maybe it can be classified according to memory usage versus memory-less methods. Some mix of the search history, that is, whether they use memory or not. Memoryless algorithm perform a Markov process as the information they exclusively use to determine the next action is current state of the search process. On the other hand, there are two types of short and long process or long-term memory. So we have two types of algorithm. One, they didn't use memory usage, and another one which is memoryless, which is use memory. One of them of using memory, which is depend on short memory, and another one is long memory. The first, which is short memory, usually keeps track of recently performed moves, visited solutions, or in general decisions taken. The second one, which is long-term memory, is usually an accumulation of synaptics parameters about the search. The use of memory is nowadays very important and very significant, and is one of the fundamental elements of the powerful of the meta heuristics. Now, the working of developing a meta heuristics or nature-inspired algorithms has three main directions. The first one is which is based on improving the current methods by controlling the parameters of the algorithms to be adaptive or self-adaptive algorithms. Another direction which is based on hybridizing different algorithms to benefit from each one. Maybe we can hybridize local search with global search, genetic with table search, and many others. And the third direction, which is very novel, which is introducing a new algorithm. And this was our source of inspiration. Again, nature-inspired algorithms can be classified into four classes. The first one, which is called evolutionary technique. The second one, which is called swarm intelligence techniques. Third one, physics-based techniques. And finally, human-related techniques. Regarding the first one, which is called evolutionary techniques, that is inspired of biology, in evolutionary algorithms, there is an initial random population that evolve over generations to produce new solutions by means of crossover and mutation and eliminate the old solution in order to improve the fitness value. This is the main structure of the evolutionary technique. On the other hand, regarding the swarm intelligence techniques, that is inspired from the behavior of social insects or animals, nature-inspired algorithms. In swarm intelligence, every individual has its own intelligence and behavior, but the integration of the individual give more powerful to solve complex problems. Regarding physics-based techniques that is inspired from rules governing a natural phenomenon. Finally, which is a very novel direction, which is human-related techniques that is inspired from the human being. Every individual do physical activities or body activities that affect his phenomena and non-physical effects like thinking and behavior or mind activities. Algorithm belong to each category. Now, this is a very good survey, but not a recent or not updated one. This survey has been conducted, I think, since 2 years ago. Yeah, I think 2 years ago, in 2019, we found that there are 17 algorithms under the umbrella of evolutionary, and there are about 79 algorithms belongs to swarm intelligence, and there are also 35 algorithms that belongs to physics umbrella or physics category, and finally there are about 8 algorithms that belongs to human related techniques. Actually, our novel algorithm, which is called the gaining sharing knowledge based algorithm, belongs to this category. Again, here we can see that this is the citation, and again, this citations since 2 years. Yeah, I think 2 years. We found that evolutionary algorithms has attracted many researchers, and then swarm physics, and as human-related techniques are very recent, they have the smallest citation, and it can be it can be easily seen that during the years um, there is a clear interest in human-related techniques at or starting from 2010 up to 2021. I mean, in the recent 10 years or in the past 10 years. Actually, this is our novel algorithm, which is called the gaining sharing knowledge based algorithm. It is developed by Muhammad, which is me, Anas Hadi, it was my PhD student, and also Ali Khater, also he was one of my PhD student. This algorithm has been published in one of the prestige or top tier journals. It is called International Journal of Machine Learning and Cybernetics, and you can download it from MathWork or also from my website. Now, regarding the application, or specifically engineering application of the nature-inspired algorithms in engineering. Actually, it is needless to mention that with the growing popularity of nature-inspired algorithms among the practitioners, parallel to the core algorithm research in nature-inspired algorithms, the application-specific research on and with nature-inspired has also been spiking over the last 5 years. Now, I highlight only the major applications where nature-inspired algorithms has been employed to solve the optimization problems. We have many tracks like electrical and power systems, such as economic dispatch, fault diagnosis, power distribution, and many others. Artificial neural networks, such as neural network training, neural network for nonlinear system identification, and also fuzzy neural net controller. Third track, manufacturing science and operations research, such as manufacturing process optimization, optimization of multi-pass turning operation and scheduling, robotics and expert system, such as space trajectory optimization, route planning, satellite orbit reconfiguration, also pattern recognition, such as classification, clustering, and feature selection, image processing, such as moving object detection, image segmentation, and multi-level, bioinformatics and biomedical engineer, electronics and communication engineering, and finally, there are many also miscellaneous, such as speech recognition, filter design, parameter estimation, and many others, many other tracks. Actually, this is some types of the required optimization function, which is very complicated. This is a definition of the most famous ones, such Achilles function, and also this is some of them or some shapes of this function. Thank you for your attention and any question. Before end my session, I would like to show that just this is a very simple example and very practical example, which is about frequency modulated sound, and we have to find the parameter of this function. We have this function. We have to minimize the error between the given one and the target one.